Welcome to discussion 13. In today's discussion, we'll be focusing on section 3.3 on trig derivatives. In this video, we'll focus on some trig derivative practice problems. So first, let's recall our formulas for the derivatives of our trig functions. So I want you to first do a quick pause for 1 minute without looking at your notes. Try to fill in these formulas for these trig derivatives. After you do that, and then refer back to your notes to see if you have them right or not. 4, 3, 2, 1. Quick pause for a minute and try to fill these in. Alrighty, so hopefully you did that. Hopefully you paused it and tried to fill these in for a minute. Let's knock them out together now. Alright, derivative of sine x is cosine x. Derivative of cosine is negative sine x. Derivative of tangent is secant squared x. For cotangent, it's kind of similar to the derivative of tangent. So it's similar in that it's a cosecant squared, and I put a negative in front of it. Okay, derivative of secant is secant x tangent x. Okay, and then cosecant x is kind of similar to this one, except these trig functions are kind of swapped a little bit. So instead of a secant, I'll have a cosecant. Instead of a tangent, I'll have a cotangent. And then I put a negative in front of that one as well. All right, so remember, to show these last three trig derivatives, it's really similar to how we showed what the derivative of tangent of x is in our lecture videos. All right, so let's do some practice problems. So this is problem 3, and I want to focus on parts C and D from worksheet 6. So we want to differentiate these functions without using the chain rule. So I want you to first pause the video for 5 minutes to try just C and D. 4, 3, 2, 1, pause it for 5 minutes to try these two. All right, so hopefully you did that. Hopefully you paused it and tried these for about 5 minutes. Let's talk about them together. So for C, I want to show how to do this in 2 ways. So method 1, I will call sort of just the direct approach. All right, so we want the derivative of secant x times cosecant x. And I noticed that we have two functions multiplying each other, the secant and the cosecant. So we can do this using the product rule. All right, so with the product rule, we'll get the first function, which is secant x. And then times the derivative of the second. So derivative of cosecant x, we may have to look this up in our table. In the early goings, we may be less familiar with these formulas. Derivative of cosecant x is negative cosecant x times cotangent of x. Okay, and then plus the second function, which was cosecant of x, times the derivative of the first, derivative of secant x. That one is secant x times tangent of x. All right, so this problem didn't tell me to simplify, and once I finish doing the derivative, it would be okay to stop here. But I do also just want to show, what this would look like if I were to simplify it. Sometimes, eventually when we do derivatives, we'll do things like take our derivative and set it equal to 0. And for stuff like that, it will be helpful to be able to simplify it. So let's practice. Let's rewrite all the terms in terms of sine and cosine. So secant is 1 over cosine. Then I get times negative 1 over sine, and then cotangent is cosine x over sine x. Okay, and we have that plus the cosecant, there's 1 over sine x. Secant is 1 over cosine x, and then tangent is sine x over cosine x. And we get some nice cancellation. So this cosine cancels with that cosine, and in the next set of fractions multiplied, that sine cancels with that sine. Okay, so we end up with negative 1 over sine squared for the first fraction, which is negative cosecant squared. And the second fraction, we get 1 over cosine squared, which is going to be secant squared x. So if I didn't need to simplify it, I could definitely get it to this point. Let's talk about one other way we could do this. So another way that we may have done this is to rewrite our function first in terms of sines and cosines. And I think it's helpful to look at both, just so we can get a feel for which one may have been more efficient. So if I were to take the derivative, and if I rewrite this is a fraction, secant is going to be 1 over cosine, and cosecant is going to be 1 over sine. And when you multiply those two, that sine will just come on this denominator. All right, so we need this derivative. And now we have this fraction, and we can evaluate this using the quotient rule. So with the quotient rule, so quotient rule says low d high, so low is cosine x sine x, d high, the derivative of 1 is 0, and then minus high, so minus 1, d low, so for d low I need the derivative of the bottom, and that will involve product rule. So it's the first function times the derivative of the second, well the derivative of sine is cosine, and then plus the second function, plus the sine x, times the derivative of the first. So the derivative of cosine x is negative sine x. We'll close that parenthesis. So this is coming from, now we're doing a product rule within this quotient rule. Okay, and all over my denominator squared. So all over cosine x sine x squared. And just as we did in method 1, let's just simplify this for practice. Okay, so if I distribute this negative 1 into the terms on the top, I get negative cosine squared x, and then I'll get plus sine squared x. Over, on the bottom, this becomes cosine squared x, sine squared x. So far that looks a little bit different than what we had before in method 1 with the negative cosecant squared plus secant squared, but we can get it in that form if we split this up into two fractions. This is negative cosine squared x over that denominator, over cosine squared x, sine squared x, and then plus the other term on the top, sine squared x, over the whole denominator, cosine squared x, sine squared x. Okay, so now I get some nice cancellation. That first fraction will be negative cosecant squared x. The second fraction, the sine squareds will cancel, and I'll get secant squared x. And now, that is exactly the answer that we had for method 1. So in fact, let me just box this as my answer. This is the fully simplified form. All right, so let's do one more example in this video. So I want to do part D, and now I want to take the derivative of 2 sine x cosine x e to the x. All right, so I notice I have this constant multiplying my function. And I can pull that in front of this derivative. So doing that, I'll get 2 times the derivative of everything that's left over. So I actually have 3 functions multiplying each other here. So what I'm going to do is I'm going to think about one function as being its own unit, maybe sine x, and then the other functions combined as a unit. So cosine x e to the x, this is going to be my second function. So this is going to allow me to use the product rule. So product rule says we'll take the first function, which is sine x, and multiply it by the derivative of the second. Let me actually write it out. Derivative of cosine x e to the x, and then plus the second function, which is cosine x e to the x, times the derivative of the first. So writing it out, derivative of the first of that sine x. And let me close that. So as we get more practice with these derivative rule questions, we'll get more and more comfortable with just sort of doing all of these rules in one step. So in the beginnings, in the early going as we do these examples, sometimes I'll sort of space it out in steps like this so you can follow the logic hopefully a bit better. But as we progress, I'll do more and more examples with the whole derivative all in one step. Okay, so we have 2 all times sine x, and now I got to multiply by the derivative of cosine times e to the x, and that's going to involve product rule. Okay, so when we do the product rule, we'll get the first function, cosine x, times the derivative of the second term, which is e to the x, plus the second term, e to the x, times the derivative of the first, which is negative sine x. All right, and then we have plus cosine x e to the x times the derivative of sine x, which is cosine x. Okay, and it didn't tell me to simplify, so it would be okay if I leave my answer like this. And that is my answer. And you know what? I feel like I didn't close this parenthesis. So this parenthesis that came from this product rule should have been closed here. And now I think it looks good.